Welcome to this video on Year 2 Pure Chapter 12 Prep Practice Answers. So this is on vectors, 3D vectors. And the main thing to say is that this is very much a continuation or a repetition of the work that was done in Year 1 vectors, except that we're moving from 2D vectors to 3D vectors. So instead of talking about ij vectors, we're talking about ijk vectors, etc. But otherwise, there's very little that's new, if anything. So question 1, the position vector of the location with coordinates 1, -2, 3 is written as, well, there's two main ways of writing it, using I, j, and k. So just I -2j plus 3k will be the vector, which gives us the location of 1, -2, 3 coordinate points. Or we can write it as a column vector, using exactly the same numbers as the coordinates, but in vertical vector form. So 1, -2, 3. And then the notation for the vector of B from A, so that's the vector from A to B, is the vector AB with an arrow indicating from A to B. The vector, question 3, the vector of B is 5, 1, 1. Or the position with coordinates 5, 1, 1, and the vector of A is 1, -2, 3. And so if you want to get the vector of B from A, that's the vector from A to B, then we need to know this general form that the vector AB is the vector OB minus vector OA. So the position vector of B minus position vector of A. In other words, the position vector of the second point minus position vector of the first point. And if we do that subtraction, we get 4i plus 3j minus 2k, or like this in column vector form. Question 4, find the length of the vector u equals 2i minus j minus 2k. Well, in 2D, we use Pythagoras, and we use Pythagoras in 3D. Might be worthwhile looking at a diagram of how this is obtained, but it does generalize. So we just simply square the 2, square the 1, square the 2, add them together, square root, and we get the length of the vector 2i minus j minus 2k. And then question 5, find the unit vector u hat. So a hat indicates that it's in the direction of u, but has a length of 1. Given that u is I plus j minus 5k. So what we need is the length of the vector u, which in this case is root 27 or 3 root 3. And so the unit vector in the direction of u will simply be the u vector divided by the length of u. So we're dividing by root 27 or dividing by 3 root 3, which is the same as multiplying by root 3 over 9 if we rationalize the square root of 3 at the bottom. So in general, you can get the unit vector in any direction by taking a vector in that direction and dividing it by its own length. Question 6, find the vector length 5 in the direction of 2i 4j minus 5k. So again, we work out the length of the vector u, which is root 45, and then we take the vector u and divide it by root 45, which if we simplify, gives us this vector here. Oh, and but we want the vector with length 5. So that's the unit vector. And now if we want to get the vector length 5, we simply need to take 5 times the unit vector. So if we multiply by 1 over root 45 by 5, we get this vector here. Question 7, find the angle between the vector u, 3i plus 2j minus k, and the y-axis. For the A level, you need to be able to work out the angle between any vector and either the x, y, or z axes. There's a formula for it, which I'll go through, but just to note that this is obtained from something called the dot product, which is not required in the specification for the Edexcel or Pearson A level, but is well worth knowing, and so it's probably worth asking for myself to go over the dot product in general, even though it's not required, because it does include this result. So let's come back to this question. So what's the angle between this vector and the y-axis? Well, what we do is we take inverse cosine of the component of this vector in the y direction and divide that by the length of this vector. So the component in the y direction is 2. The length of the vector is square root of 14. And so the angle between this vector and the y-axis is inverse cosine of 2 over root 14. Had we wanted the angle with the x-axis, for example, we would do inverse cosine of 3 over root 14. If it'd been for the z-axis, it would have been inverse cosine of -1 over root 14. So you have a very general method that allows you to work out the angle between a vector and an axis. But do have a look at the dot product, which enables you to work out the angle between any two vectors. Question 8. Force F1 is given by this vector, and then the resultant of F1 and F2 is given by this vector. Find F2. So we know that the resultant of two vectors is the sum of the two vectors. So the result of two forces in this case is this resultant force. So we know that F1 plus unknown force F2 equals the resulting force. And therefore we'll get F2 by taking the resultant force and subtracting one of the component forces. And so doing that, we get what F2 is. So just straightforward subtraction of vectors in this case. Question 9. A has a position vector given by this vector, and B has a position vector given by that vector. Find the position vector of C that lies on the line AB such that the ratio of the lengths AC to CB is 1 to 3. In other words, point C is closer to A, and the ratio of its distance from A and from B is 1 to 3. So a couple of ways of doing this. We can work out the vector AB going from A to B by doing the vector of B minus the vector of A, which is your standard formula that you should know for the vector from one point to another. And then if we want the vector position vector for C, we want to go from O to A, and then we need to travel the correct proportion of this vector we've just found out, which is AB. So if C divides the line in the ratio of 1 to 3, then to get to C from A, we want to travel a quarter of the way along this line. And therefore the position vector of C from O is travel to A from O, and then travel a quarter of the way along AB. And so if we multiply this vector by a quarter and add it to OA, we get the position vector of OC. An alternative way is to do a weighted average. And so we need to take 3/4 of the position vector of OA and 1/4 of the position vector of OB. And in general, the weighted average will be one of the components divided by the sum of the components of the position vector of one of them, and then the other way around for the other one. The way to work out which weighting to use is that because C is closer to A than it is to B, we need to take the heavier component of the vector of A. So we would want 3/4 and 1/4, and we want to be closer to A than want to be to B, and so we take 3/4 of A and 1/4 of OB. At least that's how I remember it, in case I'm confused. And then, of course, at the end, you should get exactly the same position vector of C. Just choose whichever of those methods you prefer. Either of them is perfectly valid. Okay, I hope that was useful.